All right, we got more derivative techniques. This time we're going to be looking at the quotient rule. Now the quotient rule, again, quotient is division. So I'm using the quotient rule when I have a function in the numerator and a function in the denominator. So now I need to take the derivative. Okay, so I'm going to take the low function times the derivative of the high function minus the high function times the derivative of the low function, all divided by the square of the low function. So the low function stays in the denominator, but we have to square it. Up top in the numerator is where all the calculus is, all the derivatives here. Okay, so the mnemonic device in how to remember the quotient rule is low d high minus high d low all over the square of what's below. So we have low d high minus high d low all over the square of what's below. So, low d high minus high d low all over the square of what's below. You can say it with me if you want to. Low d high minus high d low all over the square of what's below. That's your best way to remember the quotient rule for derivatives. Low d high minus high d low all over the square of what's below. Low d high minus high d low all over the square of what's below. All right, let's put this quotient rule into action. Okay, so I've got an example over here. F of x equals the square root of x divided by 3x squared plus 4. Okay, let's apply the quotient rule. F prime of x equals the low function as is, 3x squared plus 4, times the derivative of the high function, that's the derivative with respect to x of the square root of x. So we've got low d high minus the high function, which is the square root of x, times the derivative of the low function, which is the derivative of 3x squared plus 4. So we've got low d high minus high d low all over the square of what's below. So that means it's 3x squared plus 4 quantity squared. Okay, so I've used operator notation on the right side. That tells the reader we still got calculus to do. We still got derivatives to take. So we've got low d high minus high d low all over the square of what's below. Let's do some calculus. I'm going to keep that 3x squared plus 4. Okay, we've got the derivative of the square root of x. The square root of x is x to the 1/2 power. So applying the generalized power rule, I get 1/2 x to the negative 1/2. So I've got the derivative of the second part, which is 1/2 x to the negative 1/2, minus the square root of x. Now I need to take the derivative of that quadratic, the polynomial 3x squared plus 4. The derivative of that is 6x. Using the generalized power rule for the first part, 3x squared, the derivative of that is 6x. The derivative of 4 is 0, so we're going to drop that. And it's all over the square of what's below. So we've got quantity 3x squared plus 4, and that quantity is squared because that's the square of what's below. Now notice in this step, the operators are gone, which means that the derivative is done. So if I needed the derivative for something in this case, and again, what does the derivative do? The derivative is the slope of the tangent line at any x value of the given equation. So I could put this derivative to work if I needed a slope at an instant, at a value of x. Okay, so, but I'm going to clean it up a little bit here. But usually, if it's set up for the quotient rule, we're going to be allowed to leave it like that. Okay, and 1/2 x to the negative 1/2, I could write it as 1 over 2 root x, which is the derivative of the square root of x. Okay, and then I've got 6 times the square root of x times x. I could combine those. Okay, but here is a legitimate answer without the negative exponent. I just converted that over. Obviously, we could collect some like terms. In this case, multiply it out. But usually when you're studying calculus and you're using the quotient rule, you can leave the answer in the quotient rule, which was, again, low, d high, minus high, d low, all over the square of what's below. That's the quotient rule. We just put that to work and found the derivative of f of x equals the square root of x over the quantity 3x squared plus 4. Here's my derivative, and again, we could clean that up, collect some like terms, but again, usually we would keep that as is with the quotient rule in calculus. Okay.